All right, moving on. Okay, so here we go. We're going to go over those steps that I was talking about. So to find the derivative of an inverse function, here are the steps you're going to follow. To find f prime of f inverse of b for a point AB on f of x, here's what you do. First, you need to find f prime of x, but if you're only given b, so what you're trying to solve for the inverse for, then you set b equal to f of x to find a. So that's what we did on the first page, right? When we were setting our function equal to the inside of the inverse, right, to this number here. Then we find f prime of a and set it equal to 1 over f prime of a. In simple terms, right? You'd think if you're trying to solve for f inverse of b, the derivative of that, right? This is what we're trying to solve for, the derivative. Then we do the following two steps. This is just simplified. I thought it would be easier this way. One is find or set f of x equal to this number here, right? Your original function set it equal to b, and we're solving for x. Then whatever that x is, you plug into 1 over the derivative of that. Okay, simple. Don't make it too hard on yourself. All right, let's practice. Here we go. Okay, example number 3. Find g prime of -1, where g of x is the inverse of f of x. Key here, where g of x is the inverse of f of x. So that means that g of x is equal to f prime of x. So then what are we trying to actually find here? Well, if we're trying to find g prime of -1, then because g of x is equal to f prime of x, or f -1 of x, we're actually trying to find, whoops, you know what? This is not right. We're actually trying to find what is the value of f inverse of -1 prime, right? We're trying to find the derivative. All right, so that's why we're now going to do these two steps. So first step, we're looking for when is f of x equal to b. So we're looking for when is f of x equal to -1. Well, that would be when what? F of x is equal to -1 when x is 3. Then what do we do with that? Second step, we take that 3 and we plug it into the derivative and do 1 over that. So we're looking at 1 over f prime of 3, which is what? Well, 3 is our x value. F prime, our derivative, is -4. So therefore it's 1 over -4, which is -1/4. Yay! Not too bad, right? Were you with me? I hope you're with me, but we're going to do a lot more practice, okay? All right, so on the rest of this page, this is derivatives of inverse trig functions. We're going to come back to this. So what I would need you to do is skip forward 1 page, 2 pages, 3 pages, okay? I need you to go to this last page of the lesson for today where you see a table at the top, okay? This has some good practice problems. All right, so we're going to use this table right here to find the indicated values that we have here below. All right, so example number 7, find f inverse of 4, the derivative of that. So it's I always forget to read the derivative whenever I'm reading these, that little prime sign. So it's really the derivative of f inverse at 4. That's what we're trying to find. All right, our two steps, we got it. First step is what? Think about it. Did you write find when f of x is equal to 4? Hopefully you did. Well, when is f of x equal to 4? Here's our f. F of x is equal to 4 at right here when x is 2. What do we do with that 2? We plug it into the derivative, do 1 over the derivative at 2, which we come over here. So our x value is 2. What's the derivative? Oh, 1. So it's 1 over 1, which is equal to 1. Okay, follow the same method. Here we go. What about this one? Now we're looking at g inverse of -3. What's the first thing you do? Pause the video. Try this problem. You got it. All right, so will you pause the video? We're looking for when is g of x equal to -3. Can you tell I'm getting excited about this? Because I know that you guys are probably doing very well in class doing this. I hope. I'm excited to come back and see how you're doing. All right, so g of x is equal to -3. When? Well, here's g. It's equal to -3 when x is 2 again. Then what do we do with that 2? We plug it into the derivative, which the derivative of g at 2 is 2. So therefore, our answer is 1/2. All right, let's look at number 9. Looks like number 9's got a lot of work because we are writing the equation for the line tangent to the graph of g inverse of x when x is equal to 2. All right, let's figure out what this means. Whenever you see the word tangent, what does that tell you? That tells you slope, which tells you derivative. Okay, derivative of the tangent line, right? So we're looking for the derivative of g inverse of x when x is 2. So really, what we're looking for is this. G inverse of 2, what is the derivative there? All right, so what's our first step? We set g of x equal to 2. First step. When is g of x equal to 2? Well, that would be when x is equal to 4. How did I find that? Oh, we got to use our table. G of x is equal to 2 when x is 4. There we go. Then what do we do with that 4? We take 1 and plug it in, do 1 over the derivative at 4, what is the derivative of g at 4? G prime of 4, negative 3. So therefore we get x, that's equal to negative 1/3. That's our derivative, so that tells us our slope. But what are we looking for? Those of you that read directions will know that we're looking for an equation for the line. So that means that we need our point as well. So we have our x value over here. X is equal to 2. We need to find our y value, right? So we're looking for what is g of 2. And if we look back at the table, g of 2 is equal to negative 3. That's not right. Why did I have 4? G of 2. Oh, you guys, I messed up. It's not 4, it's negative 3, because we're looking at g, not f. So let's change that. Miss Barnes making silly mistakes. So g of 2, I already forgot what it was equal to. G of 2 is equal to negative 3. So therefore, we now have our point. X is equal to 2, and our y is equal to negative 3. So plug it into our formula. Let's change this to y plus 3. Look at the green, not the blue. That's a 3. Y plus 3 is equal to negative 1/3, x minus 2. Okay. All right, moving on, number 10. All right, number 10 is a little bit different. Number 10 tells us to estimate the value of g prime of 3. Use a result to explain the behavior of the graph of the function g when x is equal to 3. All right, so when it says estimate, that means that we don't have an exact value. So if we look back up here, g prime of 3, well, there's no x value of 3 that we can use to estimate g prime. So instead, we're going to have to just use our slope formula as close as possible to when x is 3. So x equals 3 would be right between x equals 2 and x equals 4. So therefore, we can use these 2 points, 2, negative 3, and 4, 2, in order to estimate the slope. So we're just going to go ahead and plug that into our slope formula, right? It's approximately our y2 minus y1 over x2 minus x1, right? That's equal to 5/2. Okay, so that is our value of the derivative of g of 3, right? So what does this tell us? How does this explain behavior of the graph of the function g? Well, it's positive, right? So what this tells us is that at x equals 3, g is going to look like it's increasing, okay? Since the derivative is greater than 0. That's the only thing it tells us, right? But derivatives are really great because they tell us the slope of the tangent line. They tell us the slope at these exact points. Okay. All right. So I think that's it for our derivatives of inverse functions. So if there's anything confusing to you in these 2 videos, make sure to rewatch it. But we're going to go back and we're going to look at now trig functions.